Hello guys, welcome to this video lecture. In this video lecture, we are discussing about electrical motoring and braking in DC motor. What is DC motor? The DC motor is a machine that transforms electrical energy into mechanical energy in the form of rotation. There are mainly four types of DC motor that are separately excited motor, series motor, shunt motor, compound motor. The basic equation applicable to all the DC motor are E is equal to Ke phi omega m, V is equal to E plus IaRa, T is equal to Ke into phi into Ia. From equation 1 to 3, we will get omega m is equal to V by Ke into phi minus Ra by Ke phi square into T, where Ra is equal to resistance of armature current, omega m speed of armature, T torque developed by the motor, Ke motor constant, phi flux per pole, Ia armature current, V armature voltage. Now we are discussing about starting of a DC motor. For normally designed machine, 2 times or 3 times of a rated current can be allowed to flow. This is the circuit diagram of motoring. When we apply KVL, then we will get V is equal to E plus IaRa, Ia is equal to V minus E by R, E is equal to V minus IaR, omega m is equal to V by K phi minus TR by K phi square. Condition for motoring. V is greater than E, Ia is positive, torque is positive, omega m is positive. At standstill condition, back EMF Eb is equal to 0, so Ia is equal to V by Ra. This show that if motor is started with full supply voltage, a very high current will flow, which may damage the motor due to heavy sparking at commutator and heating of the winding. Therefore, it is necessary to limit the current to a safe value during starting. For this purpose, variable resistance controller is used. Now, we will be discuss about braking. The term braking comes from the term brake. Brake is an equipment to reduce the speed of any moving or rotating equipment. So the process of applying brake is known as braking. There are mainly two types of braking. One is mechanical braking, another one is electrical braking. In mechanical braking, speed of the machine is reduced by mechanical process by applying brakes. In electrical braking, it depends on the flux and torque direction of the rotating equipment. In electrical braking, motor works as generator and develops a counter torque which opposes the motion. The motors, three types of electrical braking are used. There are regenerative braking, dynamic braking and plugging. Now we are discussing about regenerative braking. In regenerative braking, generate energy is supplied to the source, and it is possible when E is greater than V and Ia, that is armature current, should be negative. This is the circuit diagram. This is the voltage V, this is resistance, this is back EMF. When we apply KVL, then we will get V is equal to E plus IaRa, Ra is equal to minus E minus V by R, which is negative quantity, E is equal to V minus IaR, omega m is equal to V by K phi minus TR by K phi square. The condition for regenerative braking are V is less than back EMF, Ia should be negative, T should be negative, omega m may be positive or may be negative. Due to saturation, field flux cannot be increased beyond rated value. So, beyond rated value, current is kept constant and voltage need to vary. So, Regenerative braking is possible for speed higher than the rated value in equipment having fixed voltage source, and it is possible for both above and below synchronous speed for equipment having variable voltage source. It is only possible in separately excited DC motor in normal condition. Regenerative braking is not possible in DC series motor because in DC series motor, if speed increase, then armature current will be decreased, and with this the flux will be decreased and the condition will not satisfy. Application: hybrid and modern cars and in auto racing. Now we are discussing about dynamic braking. In dynamic braking, motor armature is disconnected from the source and connected across a resistance. So whatever energy is stored, it is dissipated through the braking resistance and other component in the circuit. In dynamic braking, resistor produce braking torque and absorb the high amount of energy generated by stopping electric motor. This is the circuit diagram. So here supply is removed, that is V is equal to 0. So 0 is equal to E plus IAR, IA is equal to minus E by R. So E is equal to minus A into R. Omega M is equal to minus TR by K Farad square. Before braking, IA is equal to V minus EA by RA. After braking, IA is equal to EB by RA plus RB. So in this case, IA is less than 0 and torque is less than 0. This type of braking is an insufficient method of braking because all the energy is dissipated in the form of heat in the resistance. Application of dynamic braking. Dynamic braking is used in variable speed drive system such as elevator, train, etc. Now we are discussing about plugging. Plugging is also called reverse current braking. In this method, the connection of the motor are reversed. So this will be create a reverse magnetic field which opposes the speed of rotation, hence drive stops. This is the circuit diagram. By applying KVL, we will get V is equal to minus E minus RA into R. IA is equal to V plus E by R. E is equal to minus V minus IA into R. Omega M is equal to minus V by K phi minus TR by K phi square. Here IA is negative and torque is also negative. When the polarity of armature terminal of the running motor is reversed, the back EMF and the applied voltage act in the same direction, but the direction of torque remain positive. As a result, current flow in opposite direction. The reverse current produced by the combined supply voltage and back EMF is extremely high. So for this, a resistance is placed in circuit to limit the excess current. After the combination of both the voltage, high reverse current and high torque is produced, which oppose the motor and slow down the motor. Plugging gives fast braking due to high average torque. Plugging is highly inefficient because in addition to the generated power, the power supply by the source is also wasted in resistance. Application of plugging. Plugging is applicable in controlling elevator, printing press and machine tools. Thank you.